Alright, this is not going to be the best. I thought that was a prelude. Alright, it's recording now.
Alright, when we're simulating a situation where the system has a leak, this is my suction line, my low side, and I'm going to go through Schrader valves. And obviously, to speed up the entire recovery process, it would be a good idea to actually remove the cores of the Schrader valve. So first I'm going to show you these tools where you can actually remove the cores and therefore speed up considerably your recovery process. I have some tools here to show you. There's different manufacturers. Here's some different brands, different styles. These are my new ones, new CD versions. But I also have this brand. What's wrong? This is supposed to be professional here.
It's very professional.
This is the Appian brand of core removal, and with this one, it does have the ability to actually take the core out and hold a pretty deep vacuum.
Let's get a close-up on that little piece.
No, you don't have to.
Okay.
Get a close-up on him. Find out why he's actually laughing like crazy.
Seriously?
We're good.
You're not helping me out here.
Now, it's obvious that I want to give each group a couple of these to remove the refrigerant core from both sides, the high side and the low side. But if you only had one of these, remove the core from the low side, because that's the liquid. So if you actually move the refrigerant out, suck refrigerant out in liquid form, it would be much, much faster. But I'm going to show you, I'm going to actually give each group a couple of these. We'll see if these old CNDs actually work. Here's how you use them. By the way, safety is kind of important, so I'm going to find my safety glasses here, especially dealing with these the high pressure liquid. Especially not high pressure liquid. So here's how. Now there's a trick to this. There's a real trick to this, and sometimes it takes a couple of attempts. So we'll first do the low side, because it's a bit safer. You attach this thing to the Schrader valve itself. You screw it down. Go kick him or hit him or something. He doesn't want to be on camera. Now this is an internal valve. In this position, I have flow to the valve. There's a stem or a core in here that moves up and down. See this? And in this position, I cannot push the stem down through that closed valve. Put it in this position so I have full flow to the valve. Now, this is nice and tight. You push the stem down, and you literally have to grab hold of the core. Grab hold of the core with what's inside here is this. Is a small little pincher right there. And it's usually that kind of wears out. That sometimes you actually have to take your needle nose pliers. Are you coming really close to this?
Not that close. Just keeping the frame around the actual thing that you're working on and not you.
Okay. You're doing it. If this looks like crap, it's your fault.
I'm not taking any responsibility to this.
You are the photographer.
You said keep you out of it.
I did not say that.
Oh, for the love of
I
God.
said don't come really close to my face because I'm not a supermodel.
Okay. I'll include you in the video.
Oh, look at this. Somebody dropped my little O-ring. That's not good. All right, so this is what actually pinches the core. Sometimes you have to crimp this closed a little bit to actually work a little bit better. So here's what I'm going to do. I'm going to put this thing in here. Now, right now, the system's off, so the pressures have equalized. So this low suction, low side pressure is actually pretty high, probably of the order of 100 pounds pressure. So I'm definitely working against a pretty high pressure here. Now, here's where you have to push down on this thing, and while you're pushing down on it, you turn it to grab hold of the core at the same time unscrew the core. So I'm pushed down, up. Now I've locked into the core, and now I have to push down at the same time of unturning it to unscrew the core itself. See, I'm pushing down and unturning it. Now, takes a few turns, and the pressure inside there will build, and now hopefully I've unscrewed the entire core. Then I close this, and I take this out, and I cross my fingers, and I'm hoping that I've actually unscrewed the entire core. Oops, I missed it. This is where I told you before, sometimes it has several attempts, and I might have to actually take my new nose pliers and actually crimp these a little bit more to actually grab hold of the core better. Let me try again.
Take two.
No, this is good, because this is what actually happens. And by the way, I've used these so many times that it wouldn't surprise me that that those pinchers have widened. So I might have to take my needles and pliers and actually. Now I'm up fighting at pretty high pressure here. Okay, I've locked onto it. Hopefully I'm unscrewing it. Sometimes it takes a few attempts. Try again. Hopefully I've unscrewed it. Yeah, this time I actually got it. That's the core. See, that's the core.
Zoom in.
No, that's the core.
If you're in this industry, I think you know what a core looks like.
It's just a Schrader valve core. All right, now set this aside. Don't lose it. Don't lose it. And you want to do the same thing to the liquid line, okay? Remove the core. Because if I open this, right now it's closed. If I open it, obviously, refrigerant is going to come out. The hole here now is, we're talking bigger than of the core is like an 1/8 of an inch diameter. So I can actually take refrigerant out very, very quickly through an 1/8 of an inch diameter compared to the hole produced by a Schrader valve core, which is like 5/16 of an inch diameter. So this is aside. Let's put this aside. Let's set up now the use of the recovery machine. Now the installation instructions say, first I have to set this up. What I don't want you to do is take these pressure gauges seriously. So they first things that have broken on these are these pressure gauges. This right here is the inlet port. Oh, this is the G1. This is the G1. I told you there were a couple of brands. I'm going to go and get the G5. This is what I want you guys to work with. So, pause. Action.
Action.
This is the one we'll use. Don't pay any attention to these pressure gauges. I think that they are probably both broken. Now, this is the inlet. So refrigerant actually comes from the system, goes in here. This is the valve. And this is the outlet. Refrigerant is basically going to my tank. And this is the outlet valve. Now, the first thing you guys have to realize is you have no idea who used this last. You have no idea what's still in there. And quite often, they will close this valve. Right now it's open, but they will actually close the valve, and you see the pressure gauge might go up. So the first thing to do, to prepare it, is you have to open this discharge valve. And if you open the discharge valve and a whole bunch of refrigerant flies out of this port, do not be surprised. The last group of students actually kept refrigerant actually inside there, inside the condensers. A condenser here and a condenser here. So don't be surprised. You open this valve and refrigerant comes out. Don't be surprised. Now here's the inlet port. And the first thing the instructions tell us to do is check the screen. So I have to unscrew this thing. To check the condition of the screen, which is gone. Quite seriously, the screen is gone. There should be a screen here. See if there's a screen on that one.
Literally so locked.
I have a feeling. My suspicion is the students saw this screen. They saw the screen plugged up with black crap, and they simply took it out. That's my suspicion. Unscrew it. Use your muscles, your fingers.
Should I record him too? He's not special enough?
You just drop it. The screens should be inside.
It's underneath it.
The screen's right there.
Where?
Use your eyes.
You drop it?
Oh!
You can edit this video.
Edit the shit.
There's a lot of editing.
I want to use that screen.
Yeah.
Gold.
And that's the screen. That's a very fine mesh screen. Very fine mesh screen. And that can get very easily plugged up. That's why they say, take a look at that screen, the condition of that screen. Usually right inside here, right inside there. Okay, so it's all done. That's prepared. I'm going to set that better. Make sure it's in there good. All right. The instructions also tell us we have to prepare this. There's two condenser tubes in here, and we literally have to prepare it. The only way to prepare it, they say, is to evacuate it. So that's quite literally what we have to do. We have to hook up a vacuum pump. We have to open this port. Now this port, there's only a little bit of line that leads from here to the compressor inside. We'll open this and open this, and we'll evacuate from here, both condensers, and here, just a little bit of hose, tubing that goes to the compressor. So we have to use a vacuum pump. It's easiest, of course, just like your evacuation project, to use a 4-port manifold. So here's my 4-port manifold. Here's my 4-port manifold to actually evacuate just the recovery unit.
Someone else wanted to do
this. These have isolation valves. This is closed, this is open. I'm going to evacuate the little pot of piping. In a minute, they actually move this up a little bit. That would have been better. Now, we've made these carts for students to use. Make it easier for students to use. Sometimes it's not. No, it's bolted to the... They drilled the holes there. Well, yeah, we'll have to re-drill the holes. All right, so we also have to evacuate the condensers. So what I'll do is I'll use red line as if you were literally evacuating a system, a high side and lower side. Take a good look at the condition of the gaskets. Make sure that they actually will seal. This is kind of suspicious looking.
What's up with your lab aim? Doesn't you do stuff like that?
Well, I hope.
Thought they were supposed to be useful.
Yeah, exactly.
We have 2 lab aids.
They should be going through this stuff.
Yeah,
so
we
they're
haven't seen one of them.
Yeah, I know. Right?
Someone should maintain this.
You know what? I'm gonna replace that because that's really kind of worn. Look at that.
I will call it lab.
Where's the stuff?
All right. When you buy these, of course, these are
He got fired.
these are sized for these hoses. I'm going to use my shredder, those pliers to actually get this out. Sometimes the pins here are screwed out. You have to unscrew them. This one, no, you just literally kind of lift out. And it comes with the... Looks like you do have to unscrew this one.
Oh.
cause.
It's getting loose. You could simply grab hold of the gasket itself and kind of rip it out. Oop. Yeah. See, right here is my the nipple. And of course, that's what depresses the core of the Schrader valve. I'm going to put that back in place so it doesn't screw out, it just lifts out. This one. This is the bad one. Now, what some people actually do, they take the bad one out and then they put it back in. They flip it upside down because now they have, this side that actually looks in pretty good shape, and they'll put this one back in place. In its place. Sometimes that works.
Those aren't O-rings.
Those are all.
I mean, not the circular O-ring ones.
Yeah. So what I'm going to do is I'm going to sort of replace it with a brand new one, and you just push it back in its seat here. So now that makes a good clean seal. So I'm going to basically take now this hose and nice and tight here and roll that, nice and tight and roll that. Feels like it's cross-threading. There we go. Nice and cross-threading.
That's gotta be hard to cross-thread that.
I'm on camera. You're on TV. Yeah, you're gonna be on
my
YouTube tomorrow.
You know what? I tried to actually upload my video to YouTube.
Uh-oh.
Oh, that's a little background music while you're working.
Keep that on. I could add some sound
We'll be
effects.
back in 5. We'll be back in 5. What, didn't work?
And now from a word from our sponsors.
Yeah.
You know what? Okay, just
Get out work from her. We should just videotape him. Yeah, that's funny.
If it's already cross-threaded, it's not gonna go back the other way.
vacuum pump. The vacuum pump we're going to use, this one, of course, has the smaller port and the large port. Since we're using the black hose, we're going to basically attach this now to the larger port. Of course, our objective is to simply evacuate the recovery machine itself, this guy, to prepare it.
You're professional.
Thank you. And now we need the micron gauge.
We're actually going to do a micron gauge.
Well, we have to evacuate this down to 500 microns. So we're definitely below 1,000 microns. It's a little bit different.
That's a gauge.
Oh, yeah. Oh, here's the sensor. Oh, really? Yeah, a little bit different.
Yeah,
Okay.
Where's the power?
Where's the calibration number?
It says Cal, what is it?
This is Cal.
I thought it says college.
No. What the hell is this? No, this is a vacuum. You know what? Just to save time, instead of having to figure out how to use this, go give me another. We're more familiar with this one anyway, so let's use these micron gauges. Of course, these have a nice feature, battery powered or AC powered, and I think the batteries are dead. So I hit battery and then calibrate. If I can move this, great. If I can't move this, the batteries are dead. And you have to replace the battery. So I'm going to put it on AC power, and if you can, please plug me in.
There's one right here.
Yeah.
Here. Are you going?
Yeah.
If you recall, you have to check the number. Can you check the number? I can't see it in this light.
2675.
All right.
Not plugged in.
That'll be
All right. We're good.
I hope that's the right voltage.
Yeah.
Okay, now it's on AC power. Now you have to calibrate it to, what was it?
2675.
2675 as accurately as possible.
Where does it say 2675?
Right there on the sensor.
Oh, okay. Gotcha.
And then I have to flick to read. It'll go all the way up to atmospheric pressure. I attach this one to my yellow utility hose. Take a look at the gasket. Questionable. And I don't want any oil dripping on that sensor, so I'm going to hang this somehow. And
Hanging off the rod.
Right there, that's all.
For that.
all right. Now this particular pump has a gas ballast feature right there. So before I put the pump on, I open the gas ballast. Wow, that thing is tight.
Second stage.
No, closing.
One stick.
Once it goes below.
I'm serious, somebody took a wrench to this gas ballast.
Monkey pop there.
This is a finger tight ballast, I mean, literally finger tight. You have to need a wrench on that.
Super seat.
They should have like little pieces.
All we're doing is evacuating this. So we have to open the valve. You know, this is open, this is closed. So open the valve right here. We're going to open this valve. This in this position it's open, in this position it's closed. We're going to open this. We have to open the red valve here. We have to open the blue valve here. Of course, we have to open the yellow valve to actually the sensor. And this particular pump, as you notice, has an isolation valve. And that's closed, and that's open.
Why would you want to isolate it ever? Just because when it's
Well,
staying in the truck?
I would suggest you buy a pump with an isolation valve, because if you did have to change the oil in the pump, it's kind of easy to isolate the oil in the pump right here. But of course, you can isolate it here too. In fact, I do both. Now this is closed. What I do is I normally turn the pump on not loaded. I'll close this. I can open this. It's open.
Is there power on?
Now I need to turn the pump on. So if you can plug me in over there somehow with the extension cord. You might have to go over here with the extension cord.
There's one right at the end there.
Right at the end, on the green pole.
Now, the switch of this pump is right here. So as soon as I turn the pump on, then I'll open this valve. Now the exhaust of the
you're
pump.
burning something.
Burning something.
Or is that just fumes going?
Yeah, it's always
Yeah, sometimes it's the residual oil vapor coming out. Now I'm going to open this, and it'll start to evacuate. Here now it's under load, right? Once I get down to 1,000 microns, I'm going to close the ballast. All I'm doing is evacuating the condensing coils in here, the condensing coils.
I don't know. I can't see.
It is kind of hard to see the oil level.
Are
Yeah.
there trigger valves on the recovery machine?
No.
That'd be silly.
Should be this.
Yeah, because then why would you be taking shoulder valves off of there if there was shoulder valves on that one?
So when you open it, no air gets in.
You know, I don't know.
Now 1,000
I
microns,
understand,
1K, I'm going to close the ballast. All I'm doing is is evacuating the two condensing coils inside here. All right, 1,000 microns, I'm going to close my ballast here. That'll allow me to go deeper. Now this pump, I don't know what the capacity of this pump is.
Very good. Very good. 4 CFM.
Oh, 4 CFM. No, gentlemen, I told you, if you're going to buy a vacuum pump, I suggest a minimum of 3. A minimum of 3. 4 is okay.
Something's leaking.
Huh?
4 CFM means how much exhaust is leaving or how much it's pulling?
Theoretically, how much actually it's capable of pulling in. 5 CFM if you could afford it. 6 CFM, obviously much more expensive, by a couple $100 maybe. But the larger the capacity of pump, the faster it's going to evacuate, obviously. But those 10 CFM pumps,
How much are those?
we're talking 10 CFM, my guess, 800 to 1,000, I bet.
This thing's losing pressure instead of...
No, it's going down.
Oh, sorry.
It's going down.
So,
So, now, as long as I get close to 500 microns, and I'm hoping that nothing's leaking here. They're just tubes here, condenser tubes. Condenser here, and that's what we're evacuating. Those
That's
condenser
to get rid of
tubes.
the old,
Residual refrigerants inside.
yeah.
Well, air, because I don't want to put air from here into my recovery tank. So focus your attention on this. I'm going to go get a tank. Actually, Mark, you guys, can someone find for me, I need one of those small recovery tanks. R22. Can you get my scale for me? You can pause it. Use your calculator.
How much did you get?
Okay, this says, say, 17 pounds, 9.5 ounces.
He's got a fund, doesn't he?
All right, so you're going to have to figure this thing out for me. I want to know how much is in there now. It's got 17 pounds, 9.5 ounces. The tare weight, that's the can weight, is, can you see what that the top would be?
TW 20s. No, can't. That's water condenser.
15.1 pounds.
15.1, so 15. All right, so the tare weight is 15 pounds. This thing weighs 17 pounds, 9.25 ounces. So how much refrigerant's in there?
2 pounds, 9 ounces, 9.5 ounces.
17 minus
15.
15, that's 2
Two.
pounds, so it's got 2 pounds, 9.5 ounces. Now, since I know it has 2 pounds, 9.5 ounces, how much more can I put inside there? The water capacity,
26.2.
that's it. So 80% of 26 is
22? 22?
Yeah.
20.8.
about 21.
Yeah.
Alright, so let's assume about 21 pounds. So the maximum I can put in is 21 pounds. I have 2 pounds, 9.5 ounces. How much more can I put inside there? So 21 pounds minus 9.5 ounces. So put, how do you convert
No, you
ounces to pounds? What are you going to do?
9 out of 16.
Yeah.
9.5 out of 16. Which is 0.6.
So 0.6 pounds.
So you got 2.6 pounds in there.
Watch your
It's
finger.
at 18.2 pounds. Oh.
17.
Well, no, it was 21. It was 20.8.
Yeah, but you've already got. Alright, go ahead.
So it's 18.2 ounces.
But you've already got 2 points.
I know, I did. I minus it.
Okay.
So you can-
18.2 ounces more.
More in there.
18.2 ounces.
Pounds, sorry.
Sorry.
My bad.
So I could put 18,
0.2 more pounds left to go, and you can put
so
it in.
0.2 pounds is how many ounces? 4.
0.2 pounds.
0.2 pounds is how many ounces? 0.2 pounds.
That's 1/5. So
so there's a
Yeah,
1 pound is 16 ounces, so it's
3.2.
3.2 ounces?
Yeah.
Okay, very good. So I could fill this thing up with the grand total of how many pounds and ounces?
The grand total?
18 point.
18 pounds.
What was the last? 0.3.
Wait, what?
What was the last thing you had on that? So it's 18.5.
18
3 ounces, yeah.
Okay, so I could put 18 pounds, 3 ounces more. I really need to know that because at that point I need to stop. All right.
But that's a lot of refrigerant.
Yeah, this does not have that.
Yeah, not even.
Okay, I'm down almost to 500 microns.
Just to do that, it takes this long.
That's why you buy an $800 CFM battery.
Okay, so what I need to do, this is evacuated. This is evacuated. So I'm going to close these valves. I'll close these valves. This one's closed and this one's closed. And now this is evacuated. That's all I needed to do. Should turn this off now. So that's all I need to do. I need to basically
going
prepare
down.
this. It's going up. Nope.
Well, he closed the...
There should be
Reading what's in there.
Yeah,
So you got a leak somewhere, isn't it?
definitely. But I was able to evacuate this quite a lot. So now I need to actually set this up now with this and my system. So here's the next step. I need to hook up all of my hoses. Now, we could use a 4-port manifold, but I think it's a little bit easier to actually go through a 3-port manifold. This is one of my brand new 3-port manifolds, and I know the gaskets are in really good shape. So here's what I do. I need to hook up the low side, my blue hose to the low side. I need to hook up my red hose to the high side. And my yellow utility hose, that's going to go, this guy is going to go straight to this port, the inlet port. Now, it's true that if I had a contaminated system, if the motor had burned out, I possibly have contaminants in the system, but they strongly suggest is an inline filter before the refrigerant goes into here to put an inline filter. But we don't have a contaminated system. There's not really much worry of that actually happening. So let's continue now with setting this thing up. And to speed up the entire process, I want to basically remove both cores. That's the core on the low side. So I'll use another tool to capture the core on the high side, because that'll speed up the whole recovery process quite a little bit. If I wanted to use my brand new tool, this is kind of cool.
$50?
No, it's more than that.
What?
Yeah, it's more
Are you
than
kidding me?
that. It has a really nice smooth valve. So I'm going to use my brand new tool on my liquid line. It works the same as the less expensive ones, but these have ability to actually hold a vacuum much better. Okay, valves in line, so that I push this down. But when I do push this down, of course, what happens is I'm depressing the core, so this thing fills it with high pressure liquid. So if you did have a 410 system, yes, you have extremely high pressure liquid inside here. You have very much, so you have to be very, very careful. That's why you use these.
Put your eye.
Yeah, so I'll push this
Put
down.
your eye right in it.
Push this down. As I push it down, I'm depressing the core, so I'm feeling the pressure. Push it down, and ooh, I've locked into the core. Now I'm unscrewing the core. I have to hold it down while I unscrew it. And hopefully, I got it. I'm going to close the valve here. Now, there is a bit of residual pressure inside here, so be wary of the fact that you get a little bit of that. Very little. Now, hopefully, I got the core. Look, no core. I got to do it again. So I told you, sometimes it takes more than one attempt.
So the core's just hanging out in there, just like loose, right? So what is it possible for it to like wobble from one side to the other, like where you get into a messed up situation where your core's not in and...
That's not good at all.
Well, yeah, of course it's not.
Then you open the valve and like...
It's a good idea. Push it down.
So how do you get these back in then? Same way you took them out?
Mm-hmm.
They just
Are
pop
they
right back
magnetic?
in?
No, not magnetic.
Should be. No, well, it's
Well,
it's got brass, right?
they've got threads on them though, so you can just screw them back in.
Maybe from you going, letting it pop out. That's why it comes up.
Here you got it.
Here's the core. Put that aside. Don't lose it. All right, now I'm going to use my 3-port manifold, and like I said, I'm going to attach the blue one right to here.
What's the reason for the other ports on the...
Oh, I'll show you.
Oh, okay.
No, there is a reason for it. A very smart reason.
I would hope so. For over $50?
They're more expensive than that.
That's what I'm saying. Go be adding random shit if it doesn't work.
Oh, look at that.
Garbage.
Horrible. Totally shit.
Garbage.
Yeah, one side. So
You got a bunch of them in here.
You know what I've seen some people do actually to have a better seal? They'll take a little bit of oil, just a dab of oil, and put the dab of oil on top of the gasket.
Depends on which kind of oil.
like when you change your oil filter in a car.
Exactly.
Don't put brake fluid on there.
So if you put a little bit of oil on the surface here, it actually tends to seal better. On your flare or whatever. Okay, so put this on here. Now, the yellow utility one goes right to the inlet of my recovery unit. Now, I'm going to take all this away since I don't need it.
I have the same set. The same manifold set. Glow in the dark ones? No. They actually make it.
Okay, goes right here.
You get those at Park Grass? You can buy them at Johnston.
What do I have right now, gentlemen, in all these hoses?
Air.
Air.
Oxygen.
Yeah, so what I need to do.
You can purge it with the low side.
They let it recovery and out.
All right, so the outlet here, the outlet goes directly to my tank. Now here is where it's kind of very, very beneficial to have extremely short hose to go from here
Take less time.
to the tank. No, there's a reason for this. Try to find, well, when you take it off, you're finished putting this in here,
You don't lose as much.
all of that, it's inside the hose, has to be blown off. So it's nice to have as short a hose as possible. Which one does it go? Which ones does it connect to? The red one or the blue one?
Blue.
No, the red one.
Yeah, because you're trying to put a vapor in there.
No, you're putting in liquid. You're actually putting.
Oh yeah, condenses.
This thing is
into a
making liquid,
Right.
condenses into a liquid, and that liquid goes in here. So you actually have to hook it up to this one. Now, gentlemen, it's true that there's refrigerant in here. Actually, there's enough refrigerant in here to actually form liquid. So if I open this, watch out, gentlemen. There's liquid out of here. Open this, gas out of here. All right, educational. It's de minimis legal release. So I need a nice short hose from here to here. Let's see if I can find a nice short hose.
Right. It's legal. Yellow, short. Red is not short.
That's kind of long.
This one's the closest.
Oh, you
That's
want?
short.
Are you gonna blow the?
You know, you can.
Are you too close that you're seeing me too close, or you have to back away because I don't want this. I feel kind of freaked out that you see a 6-foot picture of my phone.
I get to be part of you. I'm serious because I want to part. Little stuff.
So I'm gonna go. It's easier to do this What do I have in this red hose? Air. This is the downside. You actually have to purge this one too, because this one actually attaches to the red hose.
You put it in at once.
When you first have a tank, it's empty. You literally have to evacuate a tank to be prepared to use. Now, it's advantageous to have a little bit of refrigerant inside here, just a little, maybe just a blow of gas, because I'm going to use that gas to actually purge this. But because there's liquid in there, here's where it's kind of tricky. Here's what I'm going to do. To purge this, the air out of here, I'm going to open this real quick and close it. Open, close it. So then, I open this, and that pressurized liquid kind of comes out here. Be
It didn't
careful.
go in the. It didn't go in the. Oh yeah, because it's closed that out.
I might not have opened it up. So open, close. That's purging. I purged the air out of this small red hose with a crack of this thing. Just open, close. That gave me enough pressure inside this red line to actually purge the air out. So now, how do I purge the air out of all these? I have to use the system's low side pressure. I need to purge the air out of all these. So here's what I want to do. I need to open this valve. As soon as I open it, now it's kind of a good idea to start with these valves closed. Open this. Now, if I open this, and the blue can talk to the yellow.
We got a leak.
Oh yeah, it's leaking there. Because as soon as I open this, blue can talk to yellow, and it looks like this wasn't closed enough.
We might have a problem.
Or I have a
Bad, yeah. Bad odor.
So you didn't talk to the A's.
Yeah, these TAs are suffering.
Put everything you grabbed.
What the hell is a TA?
let me see.
They get credit.
Let me take let me take this
They get credit for being
off and actually see if I
Are you
have.
serious?
I think it's like an independent study.
They'll just become A's. Not good.
Oh, they get paid and shit.
They get paid.
Oh my gosh.
They get paid for this?
Some aides get paid.
Paid and the credit?
When the blue, so blue can talk to the yellow, and then purge the yellow out here. So open this, purge the yellow out here.
Seed oil.
And how you?
Enough. Tighten it down. I need to purge the red one. So if I keep this open,
Keep the blue.
Well, you probably could.
open the red one,
You said keep the blue open, right?
keep this open. Open this, so this can
They all
actually
go
talk to
together.
this. Open this.
Kind of fucking really good. So it hurt it over there?
Good enough. It's a very short hose.
Well, you got the thing closed now,
Oh
right?
yeah, this is closed.
Okay.
But everything's now purged. Nice and tight. These are closed now. All right, here's what they next tell us to do. After all of the hoses have been purged, and if you actually read the instructions, at this point we're doing a standard recovery. And the standard recovery system says, setup machine is followed by the diagram. We've done this. Connect the AC system high side to the manifold high side. The red to the high side, done that. Connect the AC system low side manifold. Done that, the blue. Connect the manifold center port to the input of the Appian, That's the yellow utility hose to the in port. Connect the Appion output to the recovery cylinder liquid port. So this one goes to the liquid port. This is where we have to, at this point, purge all of the hoses of air, and that's basically how we're able to do this. Now, make sure the input valve in the Appion is closed. This will make it easier for the compressor to start when the power is on. And it says open the liquid port of the recovery cylinder and the output valve of the Appion. So we have to open this and this. Before we turn this machine on, this and this have to be open. Now, as soon as we do open this, remember what we did? We evacuated the air out of these two condensers. So we're going to hear literally a rush of refrigerant from this to this, aren't we? So we open this. And of course, this pressure gauge, if it's not broken, will go up. Hear that?
Sucked it in.
Yep. And it says, this is the standard recovery. Then it says, after making sure this valve is open, this valve is open, and it says, open the liquid port of the recovery cylinder and the output valve, the output. So that's done. Open the liquid port on the manifold. So they want us to open this red one.
Will you keep this one closed?
No, we will. Well, as soon as we open this, we have to also open this. But why do they want us to open this and this first? Why do we want that? Why does it want us to open this valve and this valve first?
So the compressor could.
What's inside this one?
High pressure.
Liquid. So it wants us to first remove refrigerant in liquid form. So first we're going to have, now, it says this is still closed, so we're going to open this, this is closed, and we open this. We will hear a rush, not very much, not much. This is already purged. So this is open, and as soon as we open this, then the high pressure in the liquid hose will go into the yellow. But this is closed, right? That's closed. So we'll open this. It was open already? Did I open it? Okay, I opened it already. Then it says, removing the liquid first will keep the recovery to a minimum. Turn on the Appion with the on switch in front of the panel. The compressor fan should start. Then this is a very important part. Slowly, they should put that in bold and larger print and italicized. Slowly open the input valve of the Appion. They want us to literally slowly open this, because that'll put a less load on the compressor, a smaller load on the compressor. Then it says, when all of the liquid has been removed, slowly open the vapor port. So when all the liquid is removed, then we actually open this. And of course, this is already open.
Do you leave the other side open?
Yes, because then we'll take essentially vapor from both parts of the system. Now that's one of the other reasons why it's kind of nice to have a cyclass inside here, or a cyclass here in the line here, so we can actually see if all the liquid is actually gone. But because I see a cyclass here, I can tell when all the liquid is basically gone. So let's put power to this guy. Do we have this thing hooked up? Yeah. Okay, so this is the on switch right there. And by the way, notice the scale.
0.9.
What I want to do is I want to literally measure how much refrigerant is actually going in the system. So if I zero this, if I zero it, push the button, push the zero button, if I zero it, it zeroes out the scale. So anything now that's actually going into the tank, I'm able to measure exactly pounds and ounces. I don't have to do any subtracting. Isn't that kind of neat? Yeah. Okay. But keep in mind where you have to go, to what pressure, what tank capacity before we have to turn this thing off. Remember that?
18 point.
All right, but we're not going to put 18 pounds in here. So everything's done. Then it says, of course,
Do we have enough space in that tank though?
yes, they
Fine.
calculated it.
Okay.
No, because we're simulating, actually, we're not simulating, this thing's leaking like crazy. What we can't do is, basically evacuate down to below zero, because it will be sucking air through the leak. Air will go into this, air will go into this. So here's what I'll do. When it gets down to right above zero, right about like 1 pound, that's how much vapor pressure inside here, like 1 pound, then I'll simply shut this machine off. Make sense?
So you're saying there's a leak in
So no
the
air gets
system
in.
here? Okay.
There's
Yeah.
a weird leak in that one too. It's because these are all soldered.
Now, if it didn't have a leak, then of course we can go down to like 10 inches of vacuum and recover every single bit of refrigerant that's inside there. But because it's got a leak, I go down to a little bit above zero, turn it off. So let's try to see if this works. This is the rocker switch, we turn it on. Now I slowly open this guy. Literally, you do it slow. Slowly open it. And you'll hear the motor chug. Hear it working harder? No, it's wide open. 1.8. Oh, it's cycling on its limit, I bet.
Vapor, you don't
When
see
there's
any.
no more liquid in the bottom.
Oh, I see the liquid now.
No. Look at the pressure. It's way too high. 500 psi? That's open.
It looks like you're putting that much in here, but nothing's coming out.
Oh yeah, it is.
Yeah.
You got
It went
almost
up
12
from
ounces in
5. Yeah.
Now, why is this pressure spiking like crazy?
Well, the compressor's pushing it out, remember that.
Oh, we should push it. Maybe this is too full.
No.
We calculated it.
I mean, quite literally, that's...
Get some of the vapor out? I don't know. Could there be too much vapor in there?
No.
No,
That thing is
that's so low.
spiking like crazy, so I'm not sure why that's happening.
That's going to blow it up, right?
It's... I got liquid coming out of this thing. That should not be spiking, so I'm going to turn this thing out again. Ooh, it's stripped already.
Slow.
Stripped already.
No. Some things
Something's
There's too
definitely
much
wrong.
pressure in there. It doesn't want to take no more.
it's from a different class.
Close this. I think you could cut this.
So that's the thing you don't want to do
That's
is what we were doing, where it makes it explode. Is either get
That
so much
was
pressure
spiking,
or,
so
right.
that gasket was actually literally, it was like restricting the flow like crazy. So I need to open this.
Turn it on.
Now this is closed, so I'm going to turn this thing on. And the motor inside there is probably still pretty warm. Really slow. See, the high side pressure is not so high now.
Almost got a pound in there.
Going in now?
Yeah, it's 14. It's going quick now.
Now watch this pressure. This is the one we want to watch. Also watch for all the liquid gone.
We got 1 pound. How many pounds is this one?
Usually you got about 2 pounds by weight per ton for a high temp system. So if this is a 2-ton unit,
Yeah, 4 pounds. Yeah, I was sucking.
you tell me if all the liquid's gone.
This is a 2, right?
I don't know, the panel on here says 1.5 pounds.
And when it gets down to almost 0, just above 0, we'll turn this thing off. If you notice, I got 1 pound, 12 ounces in there.
But weren't you sucking up the high pressure first?
Well, this is going down too because of the type of meter device.
The TXT would not.
It's close.
So right? It's sucking something out through the meter device?
Actually, it's going through this hose right here. But because the low side pressure is falling because of that meter device, the high side pressure is falling, so is the low side pressure falling. It's falling. Now, all the liquid's gone?
There's still a little bit in there. Really?
Got 2 pounds in there.
2 pounds?
1.25.
Now let's speed up the recovery process.
It's just about done now.
Let's open both the high side and the low side. So I'm going to open this to actually chuck the refrigerant out of both sides. And I watch this.
I'm thinking how many pounds it is. Yeah, all the liquid's completely gone.
Didn't they say this is only 1.5 pounds? 4 pounds?
Now because I removed the core, it's going much faster. Good that happened because we realized that gasket has sometimes a way to blocking flow.
Yeah. I didn't even know about that. Maybe he's talking about the condenser. Put it on front. Oh, this one picks it out because it's warm. Oh, look at that stuff local over here. It's going this way. I was thought it was going this way.
Gentlemen, as soon as it gets down to 0, I turn this off. Then I can close valves.
You guys do it. just fell off by gravity.
Did you just lose?
I didn't lose it.
What happened to the cork?
They just fell off by gravity.
What happened to the other cork?
One fell off to the back.
Could you please find my parts, please?
Got one port right here. I don't know where.
Where did this come from?
It was right here.
Oh, you know what's really nice about these new ones? You can store,
I saw that.
right here, you can store extra cores.
How much is that?
This one cost, this one cost me, I think around 35.
You're almost at zero.
We want to start at one?
Zero. Because there's a leak.
Yeah, but we don't want to get moisture in there, right?
Nowhere inside here.
You might want to cut it really.
You tell me when to stop it.
It's at zero right now.
Not yet. It's almost there.
Don't you want to isolate it at the valve right here before you shut it off?
Zero.
So it takes out that refrigerant in the lines?
Okay, now I need to, because now you will get residual stuff in here and the pressure will rise a little bit. So I'm going to close these. Close this one, close this one. Now I can actually close these. Close this one. I'll close this one.
Urgent over there?
I'm going to close this one.
Because I'm hungry.
Now, I need to simply isolate this, remove this completely. So these are both closed, but so I will have a little bit of vapor in here. But what do I have inside this long hose?
Liquid.
You have to
Yeah.
pull the other ports or no?
I'm not going to close here because I'm going to put refrigerant back in. That's why a short hose works like that. Feel the hose, it's warm. Because there's warm liquid in there. Okay, so I'm going to close this. This is closed. I'm going to close this. Now, I'm going to take this one. This is my utility hose. This one, and put it right to this port right here. That's where the liquid's coming out. Because I want to put back into the system refrigerant in liquid form, because that would really speed it up. So this is still closed. This is, I'm going to have to crack open. And here's where the dangerous one, because they say in the instructions to use literally as short a hose as possible. Because yeah, I got liquid in here.
Oh, yeah, high pressure.
I got high pressure liquid in here, so be careful, because gloves kind of handy here.
Would you like a glove?
You gotta,
Have a glove.
you do it then.
He said a glove.
I'll do it. That's not that bad.
Look at that! Wow.
There you go.
All of the liquid that was inside. Didn't that burn? Didn't that hurt?
It's not that bad.
It's not that bad.
Look at his face.
I've done it
He's
before.
like,
It's not
oh,
bad.
his face, look at his face.
My finger's already warm.
Yeah. Okay.
That was a lot of liquid. I didn't think there would be that much liquid in there.
Now hold hose. That's why she as short as possible. Okay. Now I'm gonna go right to the liquid valve. But what do I have inside this hose?
Air.
So I'm gonna open, crack, purge it right here. Open, crack,
Just gotta go quick.
purge it here. Ooh. Sorry about that. That's definitely purged, right? All right.
So can't you do the same thing at the other side? If you can crack it open and the air won't go shoot out back out that.
No.
Really?
Because literally, that column inside here, the dip tube, fills up with liquid, and as soon as I open this, that liquid goes this way under pressure.
Right. It goes this way, but then you could close it and then open
But
this
you're
side.
pushing out your air this way.
Oh,
Yeah,
he's
but
saying fill up the entire thing with liquid? and pressurize it, and then just crack it on this side. So
Yeah, the air will still shoot out that way, I think. It's not like it's going to be stopped
not-
up at this end, right? It doesn't push all the air to just this end,
Yeah.
but even if you, but if there's a place for it to escape, the air will go out, so even if you crack it there...
As soon as you crack this, that whole column in the dip tube rushes this way, especially because this is under a vacuum. Or, well, I'm sorry, not under vacuum, but
So you can purge it at this end too.
Yeah,
under a much
Yeah.
lower
You can't
pressure.
purge it at that
Much
end.
lower, this is a much lower pressure.
Oh.
Now, here's what I'm going to do. I'm going to crack this open, the red one. With this open, the liquid goes through the yellow, and right into the condenser.
So you close the blue one?
Yeah, this is closed. Now, I'm going to put back in exactly what I took out. So as soon as I go down to 0, what I took out there, 3 pounds?
3 and 3.
Okay, so I'm going to open this. So as soon as I get down to 0, then I can actually close this, right?
Yep.
So open this. It's fast. It's going to go fast.
Yeah, there goes the water and the liquid.
You tell me when I get down to 0.
2 more pounds. Can you see it now?
Yeah.
You should get a shot of the...
Wow, yeah, it's going fast.
You will tell me when it gets down to 0, right?
5, 4, 3, 2, 1.
Close it?
Yeah.
There's a lot of liquid in there now.
Yeah. Now, here's the deal. This is closed, but I don't want to lose any refrigerant. I don't want to lose any liquid inside here. I don't want to lose any liquid inside here.
Couldn't you close this? Wouldn't it be faster to close this one and then close that?
Probably.
So you don't want...
You're absolutely true. You're absolutely correct. Now, so I don't lose anything, what I'm going to do is I'm going to start the unit. Go ahead and start the unit. It's an old compressor. It'll take time to...
Time delay?
No, it's not time delay. I wish it was that simple.
Come on. You can do it.
All right, pressure's going down. All right, so what I want to do is I don't want to lose any refrigerant. So I'm going to close this. This is closed. This is closed. All of this high pressure liquid, all the high pressure liquid here.
So you can open up the vapor line, right?
Exactly. So as soon as I crack this open, the high pressure liquid inside here and here will go this way, flash into a gas and going through this little thing, the little orifice I made, and go right into the low side. Make sense?
Yeah.
So I don't lose anything. And as soon as this goes down to the same pressure as here,
Shouldn't the high side be higher?
well, this is closed.
Oh.
Isolated.
I didn't, yeah.
All right, so all of that high pressure liquid here, all the high pressure liquid here, going this way, flash into a gas. These two pressures are identical. Okay. So now I could close this. I've done all I need to do. I can even turn the unit on. Now, the last step is to do what?
Just check the pressure rate.
Put the shader back.
Yeah.
I have to put the Schrader cores back in place. Now here's the downside, you could say. Now it's very easy to put the cores back in place because now the system's low side pressure is pretty low. But the problem is the high side pressure. Pretty high. And if you have a 410 system, it could be really, really high. And it'd be very dangerous. So if I turn the unit off, that high side pressure here and low side pressure here will actually equalize, right? I'll turn the unit off. All right. I only have vapor inside all these hoses, so I can take these things off, even though the vapor is could be high on some systems. Now, if you can, please, why don't you do it?
I want to see some. Has someone ever actually like took that off without putting the trader valve?
Yes.
I'm sure.
Went through the roof.
Yeah.
Now do the low side.
Oh.
You do the low side.
Oh, he's doing the low side.
Now, obviously the valve is closed here, so first got to tighten this. Back up to the shower pin, full face, and do this.
Full face.
Yeah.
Remember, be safe.
Right, now this is closed.
Yep.
So now open this.
That's how that pressure comes
You
out.
feel the pressure. Now, this is the hard part. He has to push it down and try to screw in the core of the Schrader valve.
Come on.
Not exactly easy.
It's not easy.
Because if you let go, it's just going to shoot back up, and if you misalign the
He has to
core.
push down and turn at the same time. Now, you asked me what the other port is for.
Yes.
See these other ports, gentlemen?
Yeah.
These ports? Now, if he has the core locked, screwed in place, I'm going to open this. And if I open this, there's just a Schrader valve here. If he has it locked in place, not leaking, then if I depress this core, see there's actually a Schrader valve here.
Yep.
If I depress this, nothing will come out, correct? Psst, psst, a little bit. But if the core is not in place, not screwed down tightly, exactly, so try to do that.
I am going to stand kind of behind here. I'm not going to lie.
We'll see.
Oh, I'm pushing it.
He's good.
Success! So now he can safely turn this whole thing, take this whole thing off. By the way, these things are really handy because Schrader valve cores do leak. And you can actually take the core out with the refrigerant system in there.
In your hand.
Put the caps back on. Now, are you going to try it? This is more dangerous. Because that high side is probably...
Love danger.
Danger.
Go ahead, try.
You get this much things.
They're putting back those.
He's now trying to replace the core of the Schrader valve on the high pressure liquid line. Now, if the system had been operating, especially for a 410 system, that high side pressure, that liquid line pressure could be excessive, almost 600 pounds per square inch.
Oh, that's fun. So you feel it popping back in? Or you just do it till it stops?
He has to feel its seat.
Would it be
It's
easier
not
just
easy.
to get like a vice or something? Like one of those click vices and just force it shut and then turn it like that?
I have no idea.
That would take like too much time.
All I did was I just held it down and kept turning it till I couldn't turn it anymore.
You take that.
I know what you're
use the
talking
screw.
Have you ever
Whichever.
checked somebody with it? I bet you did.
Ah, did he do it correctly?
Yep.
Very nice. Now he can safely take off the core removal. Very good. And I think that all these mishaps were very educational, I think.
Education.
It looks like next week, is he finishing up
Yep.
with the cap back on?
Todos es mucho bueno.
So what we did was a recovery and then a charging by weight, right? So everybody clap. Woo! Get a picture of everybody clapping.
Problem?
That's